And welcome back. It is the 6th of June, 5 a day, and let's just go straight to the first one. How many odd, in fact I'm going to highlight this, how many odd numbers greater than 20,000 can be formed from the digits? So the first obvious point, I've got 5 digits, 5 numbers, I'm going to use all the numbers in some way. Now what makes this tricky is an odd number means my number has to end in either 1, 7 or 9. But if I use 1, that gives me more combinations of the first number than if I use 7 or 9. So let's do these separately. So my first case is if I force this number here to be a 1, which means I've chosen one choice. However, if that number's a 1, it means I have 1, 2, 3, 4 choices for this number here. Actually, let's write that there. If I've chosen, for example, 1 and 4, it means I then have 3 choices here, 2 choices here, and 1 choice here. Multiply all these together, and that gives me 4 times 3 is 12 times 2, 24 ways if 1 is my final number. Then option 2, so 1, 2, 3, 4, 5. Option 2 is if I choose either 7 or 9 as my final number. Now in that case, there's 2 options here. So far, so good. If there's 2 options here, so for example, if I choose 9, well, therefore my first number can only be one of 3 options. And my second number, for example, let's say I choose 8, is again 3 options, 2 option, 1 option. In other words, what I choose as my last number affects what my first number can be, so I need to do them separately. Either way, 3 times 3 is 9, times 2 is 18, times another 2 is 36. Add these together and I get 60 options. Good question. Next question. A rectangular sheet of card measures. Now I know where this is going. I just having a quick look around. I'm going to work something out. I'm going to work out a volume. I'm going to work out a maximum. Oh, actually, in this case, I'm actually work out the maximum value as well. So this is a typical differentiation sort of problem. So let's just jump into it. Notably, what I'm doing here, let's zoom in here, is I'm cutting these bits out and then I'm bending it up in order to make, let's draw it properly, in order to make an open top box. Now, in this case, I don't think that actually matters, but it's just being clear about what's going on. Let's get on with the question. The question says, show that the volume in the tray is. So the volume is going to be x, which is the height, times by the width, which is 32 minus 2x, times by the length, which is 50 minus 2x. In other words, I'm taking this value and I'm taking away the x's, I'm cutting off at the side. Now I need to expand and show I get what I need to get. So I'm going to leave the x here. 32 times 50 is 1600. 32 times minus 2 is minus 64. 2 times 50 is minus 100x. And minus 2 times minus 2 is plus 4x squared. Quick check on what I'm trying to get. So I've got my 1600. I've got my 164. I've got my 4. So it's all worked out. Let's make it so it should be 1600x minus 164. Let's write that properly. Minus 164x squared. Plus 4x squared. However, I'm multiplying it all by x, it's going to be x squared and x cubed. And I've shown it to be true. Now, when it's an easier question like this, look at the number of marks. And how many marks there are should be how many lines of work you're doing, at least. So here I've shown it to be true. Next one, find the value of x for which v is a maximum. So maximum is dv dx. So I'm going to differentiate what I've just worked out. So that's going to be 1600 minus 164 times 2 is 328. And 4 times 3 is 12 x squared. And then I want this to equal 0 because I want the maximum or the minimum. Okay, I'm not going to try and factorize this. I'm just going to use a quadratic formula. So x is equal to 328 plus minus the square root of 328. Wow. Minus 4 times 12. Got to be careful because I've written it back to front. Times 1600. Okay, calculator out. I want to divide all that by 2 times 12, which is 24. Let's deal with the square root first. Okay, so the question calculator tells me that's 328 plus minus 8 root 2 481 all over 24. Now, I'm going to work out both answers. So therefore, x is equal to, now if I use the plus, I get 20.98. And if I use a minus, I get 6.356. Notice I've done them both to 4 sig fig. Now, normally what I'd say here is x is a negative, can't be that one, so it must be that one. Pause the video for a second if you haven't tried this question already. Which one do I eliminate? Okay, so hopefully you've had a think about it. The one I eliminate is this one here. And the reason I eliminate it is because if x is 20 and the x is 20, well, 20 plus 20 is more than 32, so it can't be that one. So therefore x is 6.356. If it says show or working or explain, I'm going to write something like, I don't know, 32 minus 2 times 20.98 is less than 0, therefore invalid. I'm just going to state that I understand why. Either way, find the maximum value of v. So I'm going to take my value of x, I'm going to put it in my original equation, which I've worked out here, and that's going to give me, well, let's write it out. So 1600 times, what is it, 6.356 minus 164.65356 squared plus 4 times 6.356 to the power of 3. All of this in my calculator very carefully is, and the calculator tells me 4571.30. I'm just going to say 4570 centimeters cubed to 3 sig fig. And that is it, question done. Actually only 2 questions today, but really it was 2 questions with parts. That last differentiation question, very classic, almost A-level standard-y type problem question. Hopefully that went well for you. Do let me know how you found it. Like, subscribe. See you tomorrow.